Today we're going to look at what's called the first derivative test. What the first derivative test does is it checks to see if a given turning point is a local max or a local min. And so recall, first of all, the definition of a critical number. So a critical number of f of x is some value within the domain of f, and then I want this thing to be a possible turning point of the function f. So it's such that either the first derivative is 0 or the first derivative does not exist. And this is because if the first derivative is 0, I could have something like this, and then I'm going to get a turning point here. This would be a possible value of c. Or perhaps I have something going like this. And this also is now, this is where the derivative would not exist. So once again, I have a potential local maximum at a spot where a derivative does not exist, or maybe a local minimum if I had something come in like that instead, or something come like this instead. Okay, so let's just summarize these as possibilities. So we have 4 possibilities. So critical numbers can look like, and then here are the 4 possibilities. I could have something like this, where this is my critical number c, or it could be that as well. I'll just kind of put this one in brackets. I'll focus mostly on where the derivative actually exists. So that's one type. Another type would be something like this, where this, if it's that the derivative doesn't exist, it would be something like that. Or it could be something like this. This is another spot where the derivative equals 0. Or it could be something like this. And here's another spot where the derivative would equal 0. What the first derivative test does is it helps us to distinguish which of the 4 possibilities we have here. So the first derivative test distinguishes these possibilities, distinguishes between these possibilities. Okay, so let's see how it does that. So here is the test. So first of all, the goal of the test, it's given a critical number, determine if it is the location of a local max, a local min, or neither of those two things. So this one would be local max, this would be a local min, and this would be neither. Okay, so how does the first derivative test work? So what we're going to do is we're going to evaluate the first derivative a small distance to the left of the critical number and a small distance to the right of the critical number. Okay, by small distance, what I mean is you go far enough so that you don't pass by another critical number and that you don't pass over a point of discontinuity. Other than that, it doesn't matter how far you move away from the critical point. Then you determine the sign of the first derivative just to the left and just to the right. And now let's look at the cases here again. So what would be true in this case if I were to look at splitting it up right here, let's say, on this side, the first derivative, well, here, all of these slopes of tangents here, which is what the first derivative measures, these would all be positive. So here the first derivative is positive on the left of this critical point. On the right, the first derivative is negative. When I have that situation, the first derivative is positive, and then after some turning point it's now negative, that would mean that this would have to be a local max. This would be true also for a case where it comes up to a cusp like this. Here as well, to the left, the first derivative is positive, and then afterwards the first derivative is negative, which means, yeah, it would be a local max as well. But if I look at this situation, here the first derivative is negative. All these slopes would be negative here. And then over here, this first derivative is going to be positive once I move to the right. And likewise with this situation. So when I have that situation, that is a local min. Here, if I do the same thing, look at the first derivative to the left, look at it to the right, just look at the sign. The first derivative here is going to be positive, and the first derivative here is going to be positive again. When I have that, this is neither a local min nor a local max. So that's a situation of neither. And here the first derivative is negative, and here as well, it's all going downhill. The function is decreasing, so the first derivative would be negative. So this also is neither. So just by looking at the sign of the first derivative just to the left and just to the right of the critical number, I can visualize whether the critical number would be a local max or a local min or neither of those.